Well, this is your last lesson, lesson number 8, Arrival and Approach in this instrument pilot course. Now, obviously, your flight isn't complete until you safely return to Earth at the end of your trip. In aviation terminology, this is the arrival and approach phase, and many pilots consider it to be the most challenging and rewarding component of learning to fly IFR. Now, we'll cover these specific topics for you. Stars, communications, terms and abbreviations, approach charts, radar approaches, visual and contact approaches, approaches from holding, missed approach, RVR, inoperative equipment, approach hazards, and closing the flight plan. Okay, lots to cover there. Let's get with it. First topic, stars. Back to your classroom and your instructor.
Let's study the stars. No, not Hollywood stars, but the aviation kind. These stars are not the twinkly kind you find in the night sky, but rather they are the standard terminal arrival routes, or stars for short. Pilots and ATC recommend these to improve the orderly flow of incoming traffic. The approach and arrival phase of instrument flight is where all your skills and training come together as you approach the destination airport and land. You'll use specific instrument charts called approach plates to land at airports throughout the country. Now, to use these charts and procedures, we will learn how to read and interpret the information they present and how to apply the information while flying in the system. It all begins with a star, or standard terminal arrival route. When available, the star is a bridge between en route and arrival. Now, not all airports have a star. They are common at larger and busier airports, so let's take a look at them now. Stars are similar to departure procedures, or DPs, and they are used in the same way to reduce communications, clutter, and streamline the flow of traffic into an airport. Stars may be issued by ATC whenever it is deemed appropriate. Now, if the star is accepted, the pilot must possess at least a textual description of the procedure, and if declining a star, a notation must be made in the remarks section of the flight plan. By stating no star, it informs the controller not to issue one, as you most likely do not have a copy of the procedure in the cockpit. Here's a star close up. This dark line signifies where the star begins. It starts at the Action VOR and ends at the Creek intersection. After Creek intersection, ATC will vector you to the airport.
With us in our studio today is an expert on aircraft approach, arrival, and aircraft icing, Tim Conroy. Tim, welcome.
Thank you.
Now, besides being an experienced instrument flight instructor, Tim has spent the better part of 22 years as an airline pilot flying a variety of Boeing jets for American Airlines. He's a graduate of Portland State University and has served in the Navy. Now, with more than 21,000 hours in a large variety of aircraft, Tim holds an ATP rating and is a flight instructor. He's now CEO of RAC Aviation Services, LLC. And his significant experience certainly makes him exceedingly qualified to cover such diverse topics as aircraft icing, as we mentioned, the approach procedures, and sound aircraft operation. Now, Tim, I'd like to tap into that expertise with a first question. As an airline pilot, is there ever a time you don't fly a star?
Remember that a star is a standard terminal arrival route. It is made up of route segments and crossing restrictions. If there's any weather that puts itself in either the route segment, or if you have ice conditions along your crossing restriction, then deviations are warranted. Letting ATC know what you're doing, of course, it helps them, again, effectively meter aircraft and keeps them apprised of what's going on weather-wise as well.
Let's take time now for a review question. Which is true regarding a star, A, B, or C? Well, B is the correct answer. Standard terminal arrival routes have been established to simplify clearance delivery procedures for arriving aircraft at certain areas having high density traffic. That's your answer then, B. Okay, next topic, communications, and for that we go back to the classroom and your instructor.
Okay, let's commence with communications. For the IFR pilot, communications is even more important than when flying VFR. Certain communications are mandatory for safe and efficient flight. While transitioning from en route to arrival, you need to understand who you'll be talking with and where. Now, if you remain IFR all the way to the missed approach point, the communication lineup will look like this. En route controllers will hand you off to approach controllers, who will advise you of ATIS information if time permits, and then will hand you off to the tower. If the approach ends in a landing, the tower hands you off to ground control. But if the approach ends in a missed approach, the tower hands you back to approach control, where you decide to fly to your alternate or try the approach again. Now, this is common and a pattern that reoccurs nearly every time you fly in the system. We'll talk more about using these frequencies later when we talk about approach charts. What happens if you cancel IFR and proceed to the airport under VFR? You will be expected to monitor any available ATIS for runway and weather information on your own, and if the arrival airport has an operating control tower, you will communicate with them at least 5 miles from the airport to comply with Class D airspace requirements. If entering Class B airspace or Class C airspace, VFR requirements must also be met. When IFR, as you enter the terminal area, expect radar vectors to the final approach course or expect to be reassigned at different altitudes. Now, climbs and descents should be made between 500 and 1,500 feet per minute, and if your aircraft is unable to climb or descend at 500 feet per minute, ATC must be advised. If you are being vectored to your final approach course, read back the clearance containing heading and altitude assignments. It is also important to remember while working with ATC, they express speeds in terms of knots indicated airspeed and only in 10-knot increments. Pilots complying with a speed request are expected to maintain that indicated speed within 10 knots, and if unable to comply with the request, they must advise ATC immediately of the speed that they will use. Sometimes it can be disconcerting, but a pilot might be vectored and about to pass through the final approach course. If this occurs, do not turn inbound unless an approach clearance was received. The pilot should maintain the course and query ATC. Controllers are required to advise you that they will be vectoring you across the localizer. Now, when cleared for the approach, you are only authorized for that particular instrument approach for an airport as long as the entire procedure is followed. If you are cleared for a specific procedure, such as cleared for the ILS runway 31 right approach, you must execute only that specific ILS approach.
Now, what are some of your concerns as you transition from en route to approach? What does your cockpit look like as you gear up for the approach phase? How has icing affected your IFR operations?
Well, as I leave en route
Okay.
and start to transition to the approach, I want to know what the terrain is below me. So I've got to have that aspect in my head, as well as the route segments. If I am not on a vectored route segment, I want to know where my descent points are, where I can leave an MEA to another route segment, altitude, and so on. Also, I want to try and gauge with respect to weather, icing conditions particularly, where I want to start my descent so that I can make my crossing restrictions, stay legal as far as that's concerned, stay out of the terrain, and minimize my exposure to the icing to the extent that I can. My cockpit was going to be set up for the approach. I'll have the frequency dialed in, I'll have the course dialed in, and then I'll have the approach chart out and basically using it as a checklist, starting at the top, frequency, identifier, course, minimums, and my little trick on my 182 I use before we transition to a glass cockpit on the 182 was to take a sticky and put the MDA or DH on the sticky and stick it right next to the altimeter.
Very good.
So I don't get,
Yeah.
so I have that set up already for me so I know where I'm going with the airplane. I also then come back up and take a look at the missed approach procedure, and in my head I'll have the first 2 points in my missed approach in my head so that I know where my missed approach point is, what I'm going to do after.
And put on approach, Niner Golf Romeo is back with you, 3,000, and we're on the localizer, but still at 3,000. And Niner Golf Romeo, we cleared for the approach, sir?
Niner Golf Romeo, for now, you are cleared ILS runway 22 approach. Just stay with me.
Roger, I'll stay with you. Cleared the ILS, runway 22 approach, McMinnville, Niner Golf Romeo.
Also, if on radar vectors operating on an unpublished route when your approach clearance is received, you must maintain the last assigned altitude until established on a segment of a published route or instrument approach procedure. Now let's take a look at LASSO. And LASSO is an acronym for Land and Hold Short Operations. Now it's listed here in communications since you must know exactly what a controller means if LASSO is mentioned in a clearance. LASSO includes landing and holding short of an intersecting runway, taxiway, or some other designated point on the runway. The pilot in command has the final authority to accept or decline any land and hold short clearance. As a pilot, you need to become familiar with all available information concerning LASSO at your destination airport. Now, if you request to land on the full length of the runway, or to land on another runway, or to decline a LASSO clearance, you must promptly inform ATC. Now, we have 3 other points on LASSO. First of all, if you accept a LASSO clearance, you must adhere to it just as you would any other ATC clearance. Now, there is one exception. A LASSO clearance does not preclude a rejected landing. If you need to go around, you go around. Once you are on the ground, airport markings, signage, and lighting associated with LASSO consists of a 3-part system of yellow hold short markings, red and white signage, and in some cases, in-pavement lighting.
All right, we have one question for you on communications. We're going to ask you to refer to a figure in a moment. Which frequency would you anticipate using to contact Regional Approach Control Acton to arrival? Which of these 3? Okay, we look at a figure here. We assume that our aircraft is coming in from the west. In the upper left-hand corner there, we see some frequency information. We zoom into that, and if the plane, in fact, is coming in from the west, the frequency 125.8 is the correct frequency, and that answer then is C to your question. Frequencies are shown in the upper left corner of the FAA figure, which we just looked at. Note that you must determine the direction from which you are approaching the regional airport to correctly select the frequency. Okay, we handled all that. Let's move to a new topic. Abbreviations and terms. Back into your classroom with your instructor.
Let's briefly cover aviation abbreviations. Without abbreviations in the aviation vernacular, communications would come to a crawl. For example, Automatic Terminal Information Services is comprised of 11 syllables, but ATIS, which is an abbreviation for Automatic Terminal Information Services, has only 2 syllables. So you get my drift. We need to learn the important ones. In this section, we'll cover some of the specific terms you must know to operate IFR. These terms and abbreviations are covered in the FAA Computer Testing Supplement provided to you. There is a list of definitions provided to you during the FAA Knowledge Test. Only about 58 abbreviations and terms are included, and only the important ones are covered in any depth. You can pause the lesson at any time if you want to study the terms and abbreviations in detail. The list scrolls down here alphabetically. One of the most important is DH. DH stands for decision height on a precision instrument approach. At DH, you either see the runway and land, or you do not and you execute a missed approach. different term is used for non-precision approaches, and that's MDA. MDA is the minimum descent altitude, which is the lowest authorized altitude to a non-precision approach. And MDA is used whenever the descent profile is based on time or distance instead of an electronic glide slope. Another important term is FAF, which stands for Final Approach Fix. The FAF identifies the beginning of the final approach segment of an instrument approach procedure. The FAF for non-precision approaches is designated by a Maltese cross symbol. On precision approaches, a lightning bolt symbol indicates the FAF. If ATC directs a glide slope intercept altitude which is lower than the published, the actual point of glide slope intercept then becomes the FAF. The FAP stands for Final Approach Point, and it only applies to non-precision approaches with no designated FAF, such as an on-airport VOR or an NDB. It is the point at which an aircraft has completed the procedure turn, is established inbound on the final approach course, and may start the final descent. The FAP serves as the FAF and identifies the beginning of the final approach segment. The IAP, or Instrument Approach Procedure, is a series of predetermined maneuvers for the orderly transfer of an aircraft under instrument flight conditions, starting at the beginning of the initial approach and continuing to a landing or to a point from which a landing may be made visually. GS stands for glide slope. The glide slope or glide path provides vertical guidance for aircraft during approach and landing. Applying the glide slope angle and the ground speed to the rate of descent table gives a recommended vertical speed. NPI, or non-precision instrument approach, is a standard instrument approach procedure in which no electronic glide slope is provided. For example, NDB, VOR, TACAN, ASR, LDA, or SDF approaches. A precision approach is a standard instrument approach procedure in which an electronic glide slope or glide path is provided. Examples of these would be an ILS, MLS, or PAR approach. Here's a really useful one, PT. PT is for procedure turn. This is the maneuver prescribed when reversing direction to establish an aircraft on the intermediate approach segment or on the final approach course. A procedure turn and the initial approach segment begins by passing over a facility or fix. The maximum speed for flying a PT is 200 knots indicated airspeed. Sometimes a PT is not used. In the case of a radar vector to a final approach fix or position or timed approach from a holding fix, or where the procedure is specified no PT, no pilot may make a procedure turn unless, upon receiving the final approach clearance, the pilot advises ATC and a clearance is received. A barb indicates the direction of the outbound course on which the turn is made. When a 1-minute holding pattern replaces the procedure turn, the standard entry and the holding pattern must be followed, except when radar vectoring or no PT is shown on the approach course. The holding maneuver must be executed within the 1 minute or within the published leg length. If no barb is depicted, then a procedure turn is not authorized. Headings are provided for course reversal using the 45-degree type procedure turn. However, the point at which the turn may be commenced and the type and rate of turn is at pilot's discretion. When a teardrop procedure turn is depicted and a course reversal is required, then this type of turn must be executed. A straight-in approach is one in which the final approach segment is begun without first having executed a procedure turn. Radar vectors to final are straight-in approaches. It may be followed by either a straight-in landing or a circle-to-land maneuver. Straight-in landing minimums are published when the runway alignment and the IAP final approach course are within 30 degrees of each other and will be identified by the letter S followed by the runway designation, that is SILS 34. The same IAP may furnish circling minimums for use to land on another runway other than the one aligned with the final course. These will be identified by the word circling, and no runway may be designated. The IAP final approach course may not be within 30 degrees of alignment with a runway. A IAF, or initial approach fix, is the point at which the procedure turn begins, or it can be any fix labeled IAF, identifying the start of the initial approach segment of an instrument approach procedure. An initial approach segment is between the IAP, IAF, and the intermediate fix, or final approach course. The intermediate approach segment is between the intermediate fix and the final approach fix. The final approach segment is between the final approach or missed approach point. The missed approach segment is between the missed approach point or at decision height and the missed approach fix at the prescribed altitude. A VDP is a point on a final approach course of a non-precision approach from which a normal descent from the MDA to the runway can be commenced, provided the pilot has the runway, lights, and landing environment properly identified. A sidestep maneuver is authorized by ATC to a runway within 1,200 feet of an adjacent parallel runway. You are expected to begin the sidestep maneuvers as soon as possible after the runway environment is in sight. An ILS stands for Instrument Landing System, and we see an example of an ILS right here. An ILS is a precision instrument approach which provides horizontal and vertical electronic guidance to the decision height.
Good information covered on that topic. Let's move along to a new one. And that would be approach procedures. Join your instructor in the classroom.
For many pilots, the ability to read and understand an approach chart is the most important single skill needed to fly an airplane IFR. This may be true because without that skill, the eventual approach and landing in IMC conditions could not be done safely. Now that we've learned a few acronyms, terms, and abbreviations, let's put that knowledge to good use and look into approach charts. Before we study the approach charts, you must understand that you may be asked questions on the knowledge test from the charts used in the FAA CT 8080 computer testing supplement. Here's an example of the FAA's CTT 8080 computer testing supplement. The new digital TPP airport diagrams from the FAA are currently used. Note that they are very similar. For this course, we will study the newer charts. The instrument approach procedure is also referred to as an IAP. These IAPs are used during the instrument approach. Some aspects are the same on every IAP chart. The IAP has specific design functions and objectives. It provides instructions and procedures for an orderly flight path to a successful landing, and it assures terrain clearance and runway or airport alignment during the approach. Now, the IAP has 4 distinct areas. Let's take a detailed look at an IAP here. Here on the top of the chart, we find the chart title. You can see that right up here, and it consists of the name of the approach and the runway heading. Now, the approach type is an important consideration since it defines the navigational equipment needed to fly the approach. If you have an ILS approach, you must be able to receive a localizer signal, glide slope, marker beacons, and VOR signals in addition to the regular communication radios. Here, you also note the location showing the airport name, city, and state. You can see that up here. This section on the approach chart is what we call the plan view, which is always the largest section showing an overhead view. Here's an example of the plan view right there. Now, the profile view shows how to fly the vertical descent. This is the profile view right here, and it shows how we fly the vertical approach to the airport. Now, the minimum section shows the visibility and descent limitations. We can see that section down here. And then the aerodrome data, also referred to as the airport diagram right here, provides useful information regarding the airport surface. Let's take a closer look at the plan view. We'll take a look at that right here. This is Riverside Airport in California. You can see radials coming from VORs to help identify points along the ILS feather itself, and here we have a holding pattern at the outer marker. There's a wealth of navigational information in a plan view. While we are looking at the plan view, consider the definition of straight in. If the approach is aligned within 30 degrees of the center line, the runway number listed on the approach chart, then it is a straight in landing. If it is not aligned within 30 degrees of the center line, it is not a straight in approach. However, this does not preclude a pilot from landing straight in if the pilot has the runway in sight. The plan view also lists communication frequencies data arranged horizontally from left to right in the order most likely used. The plan view also contains the MSA, or minimum sector altitude diagram. This is the obstacle clearance diagram showing safe altitudes of at least 1,000 feet of obstruction clearance over any obstacle in the defined sector within 25 nautical miles of the primary omnidirectional nav aid. The profile view shows a side view of the procedure. This view includes the minimum altitude and maximum distance for the procedure turn, altitudes over fixes, distances between fixes, and the missed approach. The minimum section is enlarged right here. The categories listed on instrument approach charts are based on aircraft speed. These are the categories that you see right across the top. Now the speed is 1.3 times VSO at maximum certificated gross landing weight. Basically, the faster you fly, the higher your ceiling requirements and the greater your visibility requirements. Here we have enlarged the minimum section for a better view right here. The straight-in ILS for runway 9er is the same across all categories of aircraft, A, B, C, and D. Note the bold numbers show the DH to be 994 feet and the visibility to be no less than 1/2 mile. The smaller numbers show that the DH is set at 200 feet above the ground. You can see that right there. Let's try a scenario. Let's say we are circling to land and our stall speed times 1.3 equals 68.9 or 69 knots. What category are we? To answer that, let's look at the chart legend. If we zoom in on the maneuvering table, we find that our known speed of 69 knots falls solidly into category A. Now we can go back to the minimum section of the chart. We can see that the circling approach section at our given speed falls into category A. And what if you were flying a higher speed than normal? Simple. You would simply use the next higher category. This section right over here advises us to use frequency 121.0 to activate the runway lighting for runway 9. Now the last section to look at is the aerodrome data. We can see an example of that right here. This includes an airport diagram and it depicts runway alignments, runway lights, approach lights, and other important information such as the TDZE, or touchdown zone elevation, and airport elevation. Let's take a closer look at an airport diagram here. The elevation of this airport is 816 feet, and the runway is 5,400 feet long by 100 feet wide. There is a real, or runway end identifier light system for runway 27, and a MERL, or medium intensity runway lighting system for runways 927 and 1634. There is also a moderately tall tower at 904 feet off to the side near runway 27. This area down at the bottom shows the distance between the FAF and the MAP is 5.1 nautical miles. It also tells you how long it takes to fly from the FAF to the MAP at different speeds. So if we were approaching at 90 knots, you can immediately see it would take 3 minutes and 24 seconds to cover the distance. Let's put this together and fly an approach. Watch as we run this simulation and see how the plane moves along the profile and plan view at the same time, with the plan view giving horizontal guidance and the profile view providing vertical guidance. Let's take a look at this one more time. In a non-precision approach, the aircraft only receives horizontal guidance. Vertical guidance is provided by combining time and distance along a specific route. This graphic illustrates localizer coverage and course width. Note that the width, 10 nautical miles, the coverage is 35 degrees of the straight-in approach course, and when within 18 nautical miles out, the coverage is just 10 degrees of the straight-in approach course. Now, here are the 4 ways in which to fly a circling approach. We can see some of those examples right here. First, there is the downwind entry, there's the dogleg entry, the crosswind entry, and finally the parallel entry. Now, a circling approach can be flown so long as the pilot has a clear view of the runway and the runway environment during the circling maneuver. Let's take a closer look at approach segments. The initial segment helps position the aircraft for the approach. The intermediate segment sets the aircraft on this particular approach to fly the procedure turn to realign inbound. The final segment takes the aircraft from the FAF to the missed approach point. The missed approach may be executed at any time from the final segment. Here we have an aircraft poised to fly the approach. The first step is to fly to the IAF, in this case the outer marker. Arriving at the IAF completes the en route transition, and the aircraft is now configured for landing. Also, the pilot is guaranteed 1,000 feet of obstacle clearance. Now let's look at an aircraft flying a procedure turn with this example you see right here. The procedure turn is used for 2 purposes, to reverse course and to lose altitude, and it must be done at or below 200 knots maximum speed. Here is additional information on some procedure turns. Let's look at a standard procedure turn first. You can see that right here. See this barb with these headings? You see that right here? Those headings instruct the pilot to fly 33 degrees outbound and 213 degrees inbound on the approach. A teardrop pattern can also be used. Here, in this particular example, the aircraft departs the locator outer marker on a heading of 067 until crossing a particular radial, then turning to form the teardrop shape and fly inbound on the 277 degree heading. Now, we also have a standard holding pattern that you can see right here, which is useful for aligning the aircraft with the final approach course at just the right altitude. There are no procedure turns while on radar vectors, or when holding at a final approach fix, or when specified by no PT on a chart. Now let's take a look at the intermediate segment shown here, which begins at the end of the procedure turn, aligns the aircraft with the final approach segment, and provides at least 500 feet of obstruction clearance. Now, here is the final approach segment we see right here. Here's a close-up of the final approach segment down here. It starts at the final approach fix at the top of the glide slope and goes down to the missed approach point, or MAP. The aircraft is preparing to land and is guaranteed between 190 feet and 350 feet of obstruction clearance. There are 2 ways to show a final approach fix on a chart. First of all, a precision approach is shown with this lightning bolt symbol right here, and a non-precision approach uses a Maltese cross symbol like we see right here. Remember, a missed approach is also part of the approach procedure. It starts at the end of the final approach segment, which is decision height on a precision approach. For non-precision approaches, the missed approach is initiated at a specific time or distance. At the missed approach point, the pilot must decide, land or fly the missed approach.
Well, we have several review questions for you on this topic. Our first one, we're going to ask you to refer to a figure in a moment. How many initial approach fixes serve the VOR DME runway 27 right Billings Logan approach procedure? Which of these 3 is correct? Well, let's go to our figure. Zoom in a little bit there. Let's count them up. We have 1, 2, 3, 4 IAFs. We go back to our question, and the answer then is B. The initial approach fixes are identified by IAF, and there are 4 for this approach procedure. All right, another question. Again, referring to a figure, how should a pilot reverse course to get established on the inbound course of the ILS runway 9 if radar vectoring or the 3 IAFs are not utilized? Which of these 3 is correct? Well, we move to a figure which shows us the information we need. Here's our approach and our holding pattern. We refer to the figure. The answer is B. Make an appropriate entry to the depicted holding pattern at Swan Lake OM INT. Now, a procedure turn need not be established when an approach can be made from a properly aligned holding pattern. In such cases, the holding pattern is established over an intermediate fix or a final approach fix. The holding pattern maneuver is completed when the aircraft is established on the inbound course after executing the appropriate entry. All right, moving along to yet another question. Again, referring to some figures. At which indication or occurrence should you initiate the published missed approach procedure for the ILS runway 6 approach, provided the runway environment is not in sight? Which of these is true? Okay, again, our figure, ILS runway 6. We zoom into the ILS runway 6, as you can see on the left there. 374 feet is our answer. So when we go back, answer A is correct. With respect to the operation of aircraft, decision height, or DH, means the height at which a decision must be made during an ILS, MLS, or PAR instrument approach to either continue the approach or to execute a missed approach. The DH for the ILS runway 6 approach is 374 feet MSL. Again, answer A. And another question. Okay, again, referring to figures, what is the MDA and visibility criteria for a straight-in LOC DME or localizer DME runway 21 or 21 approach at Portland International? What is the minimum altitude? Okay, we take a look at our figures here. We note that the make is a Piper Model PA31. The VSO is 77, so our minimum approach speed, multiplying 77 times 1.3 gives us 100.1 knots. We want to find out what category aircraft we're in. We're in category B, right there between 91 and 120 knots. And again, category B shows us 680 feet at 1 statute mile is our answer. So we go back to the question. B is the answer. 680 feet MSL, visibility 1 statute mile. Determine what category is needed. We multiply the 77 VSO by 1.3, which we did to equal our speed in 100.1 knots, which is category B, between 90 and 120 knots. We find the straight-in minimums for runway 21. Category B is 680 feet MSL and 1 statute mile visibility. Okay, covering some good information here. All right, let's have another question. Again, referring to figures, what is the difference in elevation, in feet MSL, between the airport elevation and the touchdown zone for runway 36 left? Which of these three? Well, we have to look at our figure here to determine this. Elevation is 603 feet, the airport. Touchdown zone, 588 feet. Do a little math, subtract 588 from 603, we get 15. Back to our question. The answer is A, 15 feet. The airport elevation, of course, we did the math here, 603 feet, took away our touchdown zone in feet of 588, the difference being 15 feet. There you have it. Okay, new topic. Moving down to radar approaches. And let's get you back into your classroom.
It's time to review the radar approach. Although not used much since the advent of GPS, radar approaches can be a blessing. Sometimes when your navigation radios are on the fritz, the only safe approach is a radar approach. Now there are only 3 requirements. 1 is an operating radio, 2 is an airport with a radar surveillance approach facility, and 3 is the ability for the pilot to follow directions precisely from ATC. Radar approaches are not something that you commonly do as an instrument pilot, but they are a terrific life-saving tool that can be used in case of an emergency. Let's take a look at them now. An airport surveillance radar approach is generally used in the case of an aircraft or system malfunction. The ASR approach has ATC provide range and azimuth information and is considered a non-precision approach. It requires a trained controller and an airport with radar. The controller will vector the aircraft to the final approach course and then provide azimuth guidance and inform the pilot of the aircraft's range from the runway. The pilot also will be advised of MDAs and told when to begin a descent, and also will be informed when they are over the missed approach point, or MAP. If the pilot makes a request, the controller can provide recommended altitudes for each mile on final. You don't typically use this at the end of a long flight, but an ASR can help you land safely if needed. Now, where radar is approved for approach control service, it is not only used for airport surveillance radar, but also precision approach radar approaches, and is also used to provide course guidance to the final approach course and for monitoring non-radar approaches. Airport surveillance radar, or ASR, is a non-precision approach. ATC vectors the aircraft to the final approach course, providing azimuth guidance, range from the runway, the MDA, when to descend, and when over the MAP. Precision approach radar, or PAR, provides elevation or glide path guidance in addition to azimuth and range information. Now, occasionally, a no gyro radar approach may be provided as well. A no gyro approach is where the controller provides information on when to start and stop your turns. In a no gyro approach, all turns are executed at standard rate, except on final approach when they are executed at half standard rate. Again, this is not an approach you normally fly at the end of a day, but is something you need to know in case of an emergency. Radar service is automatically terminated upon completion of the radar approach. You are authorized to use any radar IAP for which civil minimums are published.
Again, as an airline operator, how often are you flying a vectored approach as opposed to, say, a full approach?
Well, in the lower 48, we're pretty lucky. We have good radar coverage through the lower 48, even including mountainous terrain to a certain extent. Places like Steamboat, Vail, you will do a vectored approach onto the initial approach segment, but after that, while you're on the segment, you may lose radar, but you won't have to do the full procedure in a lot of places. In general aviation airports, you may have to do a full procedure in some mountainous areas, but as far as airlines concerned, it's mostly vectors.
Time for a review question. Where may you use a surveillance approach? Which of these three, A, B, or C? And your correct answer is C. An ASR, or Airport Surveillance Radar approach, is conducted by surveillance radar and provides navigational guidance in an azimuth only. This type of approach may be made to any airport or heliport having an approved surveillance approach. All right, tackling yet a new topic. This time, visual approach, and back to your classroom.
Next up is the visual approach. Did you know that most likely about 90% of all IFR arrivals terminate in a visual approach? This normally occurs when on an IFR flight plan and the destination is either marginal VFR or better.
That's right, Josh. That's been my experience. Rarely do IFR approaches terminate in IMC conditions, much less result in a missed approach. For this reason, understanding the visual approach is a central factor in IFR operations. For the visual approach, visibility must be 3 miles or greater at the destination, and the ceiling must be at least 500 feet above the MVA, or minimum vectoring altitude. As a pilot, you aren't typically aware of the MVAs because they are an altitude used by controllers for vectoring aircraft. In addition, the landing airplane must have either the preceding aircraft in sight or the airport itself and remain in VFR conditions throughout the procedure. There's more on visual approaches. If only one missed approach procedure is available, the following conditions are met. Course reversal is not required. When cleared for the approach, pilots shall not execute a procedure turn, and the reported ceiling and visibility are equal to or greater than the highest prescribed circling minimums for the IAP. Occasionally, a contact approach is only flown at airports with published approaches. The pilot must request a contact approach. It cannot be assigned.
Now, when do you, as a pilot, consider requesting a contact approach?
Well, as opposed to a visual approach, which ATC can offer you, a contact approach is something that you have to ask for. Usually, you've reached your MDA in a non-precision approach. You have ground contact. You don't see the runway, but you have ground contact. And even though the airplane is configured for the approach, you may not be, by the time you reach the runway, you may not be in a position then to make a safe arrival in a stabilized approach. That's why I don't like doing contact approaches. The second problem with the contact approach is there's no procedure for a missed approach off a contact approach. Let's say, for example, that you have left your MDA, you're maneuvering around a range shaft, another range shaft has come over your airport, and you've lost your situational awareness, and again, you've arrived at your airport maybe too high to do a stabilized approach. How do you miss? There's no really a missed approach procedure for that.
So, to get a contact approach, the pilot must remain clear of clouds and have at least 1 mile visibility from the cockpit, and must also believe the aircraft can continue to be flown to the runway under at least these conditions and remain clear of clouds. Only the pilot can make these determinations from the cockpit. Controllers cannot make these decisions for you. All right, let's kick it back over to Matt for another FAA test question.
Back for another review. This question: a contact approach is an approach procedure that may be used when? Which of these three is true and correct? Your correct answer is A, in lieu of conducting a SIAP. Now, a contact approach is an approach wherein an aircraft on an IFR flight plan having air traffic control authorization, operating clear of clouds with at least 1 mile flight visibility and a reasonable expectation of continuing to the destination airport on those conditions, may deviate from the standard instrument approach procedure, or SIAP, and proceed to the destination airport by visual reference to the surface. This approach will only be authorized when requested by the pilot, and the reported ground visibility at the destination airport is at least 1 statute mile. Okay, let's move to another new topic. This one, approach from holding. Get you back into your classroom for that topic.
In this topic, we'll cover approaches from holding. Sometimes the weather is so bad at the destination that all arrivals must use an airport that may have only 1 or 2 approaches available. When this happens, arriving aircraft are stacked up at ever-increasing altitudes in holding patterns. Usually the airplane that's lowest on the stack begins the approach, while the remainder continue to hold. Timed approaches from a holding fix are sometimes used when multiple aircraft are holding and waiting to be released for an approach. Let's take a look at those now. Now, there are some requirements that must be met. First of all, a tower must be in operation where the approaches are conducted. Next, direct communication is required to be maintained between the pilot and the approach controller until the pilot is instructed to contact the tower. And if more than 1 missed approach procedure is available, none require a course reversal. Now, if only 1 missed approach procedure is available, the following conditions are met. Course reversal is not required, and reported ceiling and visibility are equal to or greater than the highest prescribed circling minimums for the IAP. And finally, when cleared for the approach, pilots shall not execute a procedure turn.
Welcome back to the studio for your review. This question: when making a timed approach from a holding fix at the outer marker, the pilot should adjust the, how would you finish that sentence? Which is correct, A, B, or C? Well, your correct answer is C. Each pilot in an approach sequence will be given advance notice as to the time they should leave the holding point on approach to the airport. When a time to leave the holding point has been received, the pilot should adjust the flight path to leave the fix as closely as possible to that designated time. All right, your answer again, C. Okay, moving to a new topic again. This time, missed approach. Take it back to your classroom and your instructor.
We'd be amiss if we did not study the missed approach subject. There are times when, in spite of your best efforts to fly a perfect approach using the best radios, you still can't land at your destination. That usually happens because of poor visibility. When this occurs, you must execute a missed approach. Now, a missed approach consists of flying a precise series of legs and altitudes to a missed approach point. At that point, the pilot has the option of trying the approach again or proceeding to the alternate destination. The missed approach segment is a key tool to flying instruments safely and must be committed to memory. If you do not see the runway landing environment at the critical deciding moment, you can quickly and easily initiate the published missed approach procedure, maneuvering the aircraft safely away from the ground and any obstacles. The missed approach segment provides a specific flight path and altitude to fly and will return you to a point where you can decide if you're going to try the same approach again or proceed to an alternate airport. But when do you start the missed approach? Well, let's say you make an early decision to fly the missed approach. In this case, you must continue at or above the minimum descent altitude or the decision height until you reach the missed approach point, and then you can execute any turning maneuvers associated with the missed approach. Now, let's say you are circling to land and visual contact is lost. How do you fly the missed approach then? Well, you make an initial climbing turn towards the approach runway and continue the turn until you are established on the missed approach course.
Now, aside from not seeing the runway environment, what are some reasons you might decide to execute a missed approach?
Well, I think we kind of get wrapped around the axle with the approach issue a bit. We kind of, as pilots, we shoot the approach, we expect to land. And I think we need to back away from that a little bit. There's an old joke where takeoffs are optional, landings are mandatory. Well, I think that landings are also optional. There may be a condition where you may have to be ready for a missed approach, whether it's a VFR or IFR. And I think if you kind of have the missed approach in mind and that the landing is optional, then it won't be a surprise.
Outstanding.
If I had an equipment failure, either ground or airborne, I've had that happen on an approach into Reno in a snowstorm where I had to miss the approach because the ground equipment failed. There is sudden changes of wind. Maybe you're flying the airplane and you get a sudden change of pitch, power to maintain speed, which could be indication of wind shear. An increase in crosswinds outside of your limits are good reasons to miss the approach.
So be as prepared as you can be for pretty much any consequence.
Be aware. The main
Very
thing is
good.
be aware and maintain your situational awareness.
All right. Okay, taking time again for another question. If an early missed approach is initiated before reaching the MAP or missed approach point, the following procedure should be used unless otherwise cleared by ATC. Your answer is A, B, or C, which is correct? The correct answer is A. When an early missed approach is executed, pilots should fly the IAP as specified on the approach plate to the missed approach point at or above the MDA or DH before executing a turning maneuver to ensure terrain obstacle clearance. That answer again is A. Okay, let's tackle yet another topic. Moving to RVR and back to your classroom.
The next subject is runway visual range. Now here's another one of these abbreviations learned earlier. It's RVR for runway visual range. Depending on the aircraft, there are times when you may only commence the approach or depart the airport under certain minimum RVR conditions. RVR is an acronym you'll see associated with landing minimums, and you'll also hear it on certain weather broadcasts. Now, RVR stands for runway visual range. RVR is an instrument-derived value representing the maximum horizontal distance down a specified runway where a pilot can see and identify standard high-intensity runway lights. RVR is always reported in hundreds of feet. Now, if minimum visibility for an instrument approach is stated as an RVR value and RVR is not available, then you can get the corresponding statute miles in FAA's Legend 11 like you see right here. Now you can see that a reported RVR of 1,600 feet is equal to 1/4 mile visibility measured in statute miles.
And back once again to the studio for a review question. If the RVR, runway visual range, is not reported, what meteorological value should you substitute for 2,400 RVR? Which of these is correct? In order to arrive at that, we're going to have to look at a legend here. And we can zoom in, as we do, and show that, in fact, 2,400 feet RVR is a half statute mile visibility. Go back to our question, which one's correct? C. Use the RVR meteorological visibility comparable values in the FAA Legend 11 to convert RVR feet to visibility statute miles. 2400 RVR can be substituted for a ground visibility of 1/2 statute mile. Okay, next topic. This one, inoperative components. We'll take you back to the classroom now.
Let's continue with the study of inoperative components. Remember Murphy's Law? There's a saying amongst pilots that it is a rare day when every single component in or on the aircraft is working simultaneously. Well, the FAA understands this and prescribes certain procedures when dealing with inoperative components. And what do we need to know about inoperative components? Well, normal approach minimums with all ground equipment in operation are as published on the approach charts. However, if a ground component or visual aid is out of service or not used by the pilot, the minimums may be raised. Now, if more than one component is inoperative, the larger of any two minimum adjustments is applied. Now, we can find this information shown here in Legend 22 provided by the FAA, highlighting how this information is displayed and might apply. Sometimes it pays for the pilot to think of all possibilities rather than just accepting the published minimums. As an example, if an outer or middle marker is inoperative, a compass locator or precision approach radar approach could be used as a substitution.
Well, time for another question. Which of these facilities may be substituted for an MM or middle marker during a complete ILS IAP? Which of these facilities may you substitute? Correct answer is B, compass locator and precision radar. The basic ground components of an ILS are the localizer, glide slope, outer marker, middle marker, and when installed for use with Category 2 or Category 3 instrument approach procedures, an inner marker. A compass locator or precision radar may be substituted for the outer or middle marker. All right, that's your answer, and we have a new topic. This time, hazards on approach. We'll get you back into your classroom for that topic.
Next up are hazards on the approach. No two airports have exactly the same approach procedure. Some use an ILS, others have a VOR DME approach, while yet others may only have a circle to land NDB approach. And when considering safety, the ILS approach is the gold standard. Circling to land in a dark night over an airport located in the mountains ranks near the top when contemplating hazards on approach. The two hazards during an approach and landing do not have any direct relationship to IFR flight, but you must plan for them for any flight. Now, these two are hydroplaning and wake turbulence involving wingtip vortices. And while you're familiar with these from your private pilot days, we'll refresh your memory on them here since they do apply to instrument flight as well. Rain, snow, and sleet can make a truly interesting IFR flight, but they also cause hydroplaning just when you think the flight is safely over. The most likely conditions for hydroplaning occur when standing water or slush is present on a runway with a smooth texture and the landing aircraft is still moving at high speed. The best way to prevent the possibility of hydroplaning is to apply moderate braking after the wheels have a chance to spin up, and if you have an anti-skid system in your aircraft, make sure to turn it on. Now, you are less likely to think about wingtip vortices and wake turbulence when you are completely focused on shooting an approach through the clouds, but they are still there, waiting for the unwary pilot. Remember, the strongest wingtip vortices are generated by airplanes that are heavy, aerodynamically clean, and flying slowly. Now, these are just the types of aircraft you might expect to see taking off in front of you as you are breaking out of the clouds and completing an ILS approach. These vortices drop lower than the generating aircraft and can move laterally across the ground. Now, this means you must think about the possibility of wingtip vortices laterally traveling into your landing path from a parallel runway where a larger aircraft just departed. Now, if there is a crosswind, the wind can hold one of these laterally moving vortices from a plane departing in front of you right over your landing runway. This means if you break out on an approach and see a jet landing further ahead of you, plan to land past the jet's point of touchdown to avoid any vortices. Taking off, you want to lift off prior to the departing aircraft's point of rotation. In closing, why don't we study closing the flight plan? Unlike when on a VFR flight plan, which generally requires actions by the pilot, such as radio transmissions to ATC or a phone call, IFR flight plans are usually closed by ATC upon arrival at the destination. However, as in most rules, there are exceptions, for example, when landing at a non-towered airport when completing an IFR flight plan. Now you've had a safe, successful flight, your passengers are happy, and you're patting yourself on the back for a job well done as you taxi to the ramp. But now is not the time to forget to close your flight plan. Now if you landed at an airport with an operating control tower, they will close your flight plan for you. But when you land at any other airport, it is your responsibility to close the flight plan with the last controller or the nearest flight service station. Now, these are the same flight service stations providing airport advisories at non-towered airports. Since closing the flight plan is the last section in this lesson, I can't think of a better way to close out the section than to end on an FAA test question.
Okay, let's take a final question for our final topic in this lesson. When may a pilot cancel the IFR flight plan prior to completing the flight? At which time, A, B, or C? Well, your answer is C. An IFR flight plan may be canceled at any time the flight is operating in VFR conditions outside Class A airspace by the pilot stating, "Cancel my IFR flight plan," to the controller or air ground station with which they are communicating. Okay, final lesson, Lesson 8, Arrivals and Approaches. That's it for this lesson.
Now we have closed out this section on approaches and arrivals. This could be one of the more enjoyable sections in your study, and the reward of flying approaches in the system, first with your instructor and then as your confidence grows and you earn your instrument rating, can be richly rewarding and satisfying. Return to the materials anytime you want to refresh your memory, and I'll look forward to seeing you again in another ASA section or out there flying in the system. Until then, and for Stenbach Communications and ASA, I'm instructor Josh Pruzik, and it's been a pleasure to be your instructor during these lessons. May all your flying be safe and enjoyable.